ever wonder why most girls' voice
is at a higher pitch than most guys?
Or why different people have different voices?
Or why does musical instrument have different sounds? In this case, why guitar and trombone differ in sound?
Well, it's due to natural frequency, voice vibration, resonance, and stationary waves.
Today we'll be using different musical instruments to explain the difference in sound and pitch.
Let's understand the general concepts first.
When an object vibrates, they tend to vibrate at a particular frequency, or set of frequencies. This is known as the natural frequency.
Force vibration is a tendency of one object to force another adjoining or interconnected object into vibrational motion.
Resonance occurs when one object vibrating at the same natural frequency of a second object forces that second object into vibrational motion. The result of resonance is always a larger vibration, thus larger amplitude and hence louder sound. As mentioned earlier, all objects have a frequency or set of frequency with which they naturally vibrate when disturbed. Each of the natural frequencies at which an object vibrates can be shown in a standing wave pattern.
When an object, like for example the body of the guitar, is forced into resonance vibration due to the air particles vibrating in the instrument at one of its natural frequencies, when a string is strummed, it vibrates in a manner such that a standing wave is formed within the object.
The wave will overlap each other because the wave will bounce back when it reaches the end of the instrument.
By observing these stationary waves, you will be able to find the speed and the wavelength.
After finding the speed and wavelength, you'll be able to find the natural frequencies. All this is linked to the formula frequency equals to speed divided by wavelength.
There are 6 strings, each having a different linear density. For wider strings are denser, and other factors are different tension and different length.
The speed at which waves move through the string is dependent on the properties of the medium. In this case, the tightness, aka tension, and linear density of each string.
Changes in these properties would affect the standing wave pattern produced, and hence the natural frequency of the particular string.
By pressing the strings at the frets, it will also affect the wavelength and the natural frequency at which a particular string vibrates as it shortens the string.
This is why the sound changes whenever you change the position you press the string.
The tube of any wind instrument acts as a vibrating air column, in this case a trombone.
The air in the column will vibrate due to the vibration and pressure of the musician's lip.
A trombone works in a way that when a slide is pushed away, it lengthens the column. The pressure will then decrease where particles have longer distance to vibrate and bombard the walls of the column. This will then increase the wavelength while still at the same speed, causing frequency to decrease and having a lower pitch.
The opposite occurs when you pull the slide in.
So, we have explained how our sound made. Now, why are the sounds of musical instruments different? The reason is because different instruments produce different sound because of the different waveform created by the instrument.
Areas of least vibrations are called notes, and areas of most vibrations are called antinodes.
Some waves do not interfere equally and hence they would either cancel out or add up in amplitude. This repeats and creates waveform for each wavelength. The cycle repeats for a period of time, creating overtones, which are multiple waves of the waveform of the instrument. This applies to everything you hear.
Oh, it seems like it's time for us to end the video. So, you all now know more about this phenomenon and how it affects our lives. You can say that you are smarter now. Please go to your respective venues and have a good day of learning.